Today, we have a presentation from one of the leading silver paste supplier, Fusion, represented by Jian Bao, who is a technology director at Fusion. So he has been focusing on high performance paste development and application for PERC, TOPCon, and heterojunction as well. But I think today he will mainly focus on PERC. So Jian, the floor is yours.
Yeah. Hello, everyone. Can you hear from me?
Yes.
Okay, so let's start. Is that okay?
Yeah.
Okay, so I'm Jian Bao from Fusion. It's my pleasure to accept TaiyangNews to invite us to attend this conference. And since the topic is pushing the PERC to its limit, so my presentation name is Advanced Metallization Solutions for PERC solar cells. And the presentation including 4 parts. First is a brief introduction of Fusion. And the second is solar cell and its corresponding metallization trends. And the third is the paste relevant. And finally, a brief summary of my talk. Fusion founded in August 24th, 2015, about 7 years ago. And our business areas, including 4 parts, including the PV, EV automobile, and consumer electronics, and semiconductors. And since R&D is core for high quality solar paste performance, so we spend a lot of resources in R&D development. So currently we have the total solutions for PERC solar cells, TOPCon, heterojunction, and also including the RBC solar cells, HBC solar cells, and the perovskite. So currently, our market share is about 45% in global market, and shipment is over 130 tons per month, and ranked #1 in civil paste field. And based on multifunction platform, we also developed other conducting materials, including 5G, LTCC, HTCC, and conducting materials for car reflectors. And currently, our R&D center is based in Shanghai and the plant based in Changzhou. And the capacity is about 150 tons per month current, and delivery is over 130 tons, I just mentioned. And the new plant, the capacity will be over 3,000 tons per year. So we can see that since founded in 2015, 6 years passed, and the market share increased from 5%, 15%, 30%, and the current 45%. So it's a very incredible performance. And currently, we have all kinds of, including the screen printing tools and firing furnace and RV testers in our lab to simulate the customers' conditions, and we can copy these results to customer side, so the results can be repeatable. And also, we have metrology lab in our R&D center, including contact resistance and SEM and all for R&D which is needed. And before the paste delivered to customer, we will check the viscosity and solid contents and FOG of the paste, and also we'll check the pore strength before deliver our product to customer, so we can promise the paste quality before customer side. And second, I want to introduce our concept of the cell technology and the metallization trends. And from this slide, we can clearly see that currently still the PERC solar cells. At the beginning, about 6 years ago, PERC solar cells is about only 21% above or low. But currently, PERC solar cells approach to 23% or a bit higher. But I think at the end of 2022, the efficiency will approach to 23.5%. And also we can see that passivated concept contact concept cells, including TOPCon and HJT cells, the efficiency is about 24.5, but it implies, or it has some hints that maybe currently high efficiency will be heterojunction solar cells or TOPCon solar cells. But still we can see that from PV info link, the mainstream or the currently main capacity of cell is still the PERC solar cells, and only small volume can attribute to the TOPCon and the heterojunctions. Why? I think the main problem or the main bottleneck is still the cost. We can see that from this slide, metallization cost for heterojunction, it is about 2.3 times higher consumption compared to the PERC solar cells, and the TOPCon still about 30 to 40% higher than the PERC solar cells. So although PERC solar cells the efficiency is a bit lower than the heterojunction and the TOPCon solar cells, but it has advantages of its low cost compared to other high efficiency solar cells. So currently, since today's topic is about PERC solars to push the PERC solar cells to its upper limit, I think we still have space to improve PERC solar cells, not only just to pursue the high efficiency solar cells such as TOPCon and HJT or RBC, for example. And just mentioned that heterojunction and the TOPCon solar cells, its drawback is the cost is much higher than the PERC solar cells. So new metallization technology also tried, including the plating, pattern transfer printing, and the smart wear, but still have some problems in mass production, including the capex and including the yield, for example. So still need improvement. And for heterojunctions, a new concept is silver coated copper paste, but currently still on the reliability test check and still need a long-term printing check. So we are just take care of this new metallization technology. And for metallization solutions for PERC, this is my emphasis. And currently, since the efficiency is about 23.2 to 23.4 currently. So how to still continue improve the efficiency for PERC solar cells still need and for metallization part, we can see that first we need to optimize the optical and electrical, and the third is the recombination. So narrow opening is always not out of art, and currently narrow opening can reduce the cost, and the second also can improve the short current to get more light into the silicon substrate. And the second, we should be careful is, although narrow opening can reduce the short current, reduce the light shattering losses, but still maybe face a new problem is contact resistance. So how to try to balance the contact resistance and the shedding loss is a technique. So at the year of 2021, we have achieved the HOR 18 micrometers HOR screen patterns in mass production in our customer side, and the after printed the line width is below 30 micrometers. So also 500 millimeters per second printing speed also achieved, and so this year I think the screen pattern should be applied about 15 micrometers, and after the printing, after the firing, the line width should be about 25 micrometers. So this is for efficiency improvement, also for cost down for metallization, especially for silver paste. And for cost downs, we also use the domestic silver powders and use the low solid contact to reduce the printing amount or reduce the lay down property. And this chart can clearly see that the screen pattern, after the screen pattern shrinkages, the line width decreased from 40 micrometers to last year 30 micrometers, and this year will the line width should be about 25 micrometers. And as the line width decreased or the screen pattern decreased, we face long-term printing ability. But still we have the space, or the potential line width should be about 20 micrometers with current screen pattern technology, or just printing screen pattern printing method. And for paste optimization to match the narrow opening printing requirement, we need to optimize the silver paste, including the silver powders and the glass system or glass freight system and organic. So as to solve the long-term printing problems. And for glass, for silver powders, smaller and smooth surface should be acceptable, or it is much better to satisfy the lay down property. If particle size is bigger or the FOG is bigger, we can see yield problems, yield issues occurred after the firing process. And another thing is we should select the suitable glass freight, so as to we can get a wider firing process window. And another thing is we should control the spreading effect. And here we have to choose the suitable glass and the suitable civil SSA surface areas, and need optimize the organic system to get a very good aspect ratio property. So as to get a good short current, and need to optimize the rheology and 6 trophy and the viscosity of the paste too. And another thing is we need to adjust the glass freight to the corrosive to the substrate, including the silicon nitride and silicon substrate. If not controlled very consistently, the VOC will decrease much. So here it's very sensitive. We need to select the usable or select the suitable glass freight, for example, including the type and the category and the ratio in the paste. And currently, our paste, our product can match about 40 micrometers opening, and also used in our customer side in their mass production fab. So I think this year we can we will develop more narrow opening screen pattern technology. We will collaborate with screen pattern vendors, and the target is to below 25 micrometers after the finger line printed onto the blue cells. And also for busbar paste, we still developing the floating technique, and especially for cost down target, and we will tune the solid content in the paste, so lay down will also decrease. So here we still need to, at the meantime, we still need to balance the lay down and the post stress to promise customers reliability need. So finally, I will give a brief summary. So currently, still mono-PERC solar cells still the mainstream, at least at the next 3 years, due to its low cost of owner. It's better compared to the TOPCon and HJT solar cells, and efficiency. And about the efficiency, maybe about 0.3 or to 0.5 compared to current status, and we still have the cost down space. And currently 14 micrometers openings can be applied on mass production, and the next step maybe 12 or narrow will also tried in lab, and if amateur we will apply to customer side. And for new metallization such as plating and stencil, for example, pattern transfer printing and smartware and silver coated copper, we still should be given special attention. So that's all. Thank you, audience.
Thank you, Jian. Thank you very much for this nice overview on the metallization segment. So I don't know if I missed this slide or missed the information, but what is currently the laydown for a PERC cell for M10 and G12?
We can calculate the laydown with the power and the laydown. So we can here, this slide can see that the laydown of PERC cells is about 11.2 micrograms per watts. And for heterogeneous, yes.
I mean, instead of going per watt, so I really want to know what is the general industrial average, milligram per wafer M10 and G12. Do you have any idea?
Yes, so we can
ballpark figure.
I think we can calculate we just calculate with the actual, for example, 182 millimeters, for example, TOPCon, and we calculate the efficiency, we calculate the laydown, and then laydown divided by power. So we get this data. Yeah.
Okay. All right. Okay.
And for example, for 166 wafers for HJT, maybe the laydown is 180 micrograms per pieces.
Yeah. No, I was really looking for something with PERC more straightforward, but I think, yeah, one can easily calculate from this. So, okay, thank you very much for your very insightful talk on the metallization pace.
Yes, thank you, Chudori. Yeah, thank you. Yeah, bye-bye.
Bye-bye.